So this is the Ginus.ai webpage. Going to the top right corner, you can click at login and it will redirect you to the sign in page. If you don't have an account, you sign up here. Otherwise, you put your credentials and you log in. So this is the front page. There's the home page, dashboard, my projects, visualizations, upload new data, and my results. Starting from uploading new data. So the first step is to select a project name. Let's say we add a new project name. Let's name it Ginus.ai Demo 1. And then we have an upload name. The reason why we have this functionality is because we have the chance to upload multiple files and integrate them. It could be similar files, let's say from the same source, week 1, week 2, or month, January, February, March, etc. Or it could be from a different source, like from an ERP from our ERP, or the WMS of our third party, or a transport carrier from the TMS. Let's say that this is month 1 from WMS. And this is one of the key functions and key benefits of using Ginus.ai, where you have the luxury of integrating different structured files into the same one. So quickly you browse, you select the file you want to upload. It takes a few seconds for Ginus.ai to read the headlines, the headers on the columns of the spreadsheet. If you want, you can download this, which is like a guide where you can replace your headlines with the what Ginus can understand to speed up the process. Or you can simply let it and use the ones you already have. Now, after a few seconds, we click continue, and then Ginus is reading here. We can see on the left side, it reads the headers of all the columns. So in the file that we have uploaded, we have 101 columns. It is a little bit exaggerated for the purpose of this demo. Normally you have 20, 25, or 15, depending. And this is one of the few manual tasks the user has to do. So in this stage, we basically match the columns of our spreadsheet with the database of Ginus. For example, we have source, company code, and then all these headers, we split them basically into 8 categories. 5 from to shipment, logistics, product, and 3 related to unit of measure, which I'm going to explain in just a second why we have 3 different units of measures. So back to the field name, source company code. So this is the header in one of the columns in our spreadsheet. And this is source from company code. So this is the point of origin, let's say, and we have the options of matching it. In this case, it's the company code or company ID here, and then we select company name, location, ID and name, the type, whether it's a warehouse or a port or a co-packer or whatever, region, city, postcode, address, latitude and longitude. Now, if we don't have the coordinates, Ginus.ai is going to find them based on the address. If we don't have the address, it will bring us the coordinates of the postcode. If we don't have a postcode, on the city. If we don't have the city, it's going to be flagged as an error, simply because it doesn't make any sense to have coordinates of a whole region or a state. If you do have coordinates, Ginus is going to reverse geocode and try to find and match whether they are correct or not. We are using Google Maps, which are the most accurate when it comes to batch geocoding compared to any other service or map services in the market. So the from and to, they have the same type of categorization and options of description, simply because it's the point of origin, the point of destination. And the point of these 2 groups is to match the coordinates and to help Ginus.ai structure what is the location. And then we have the category shipment. Under this category, We have information where we can match supplier POD number, supplier PO, purchase order number, an internal order number, the supplier PO date. We'll discuss in a sec about the dates, then the formatting, shipment category, shipment ID, a cost, the POD number or a drop number, delivery date, and so forth. Then we have the category logistics, under which we can say the load type, carrier name, vehicle ID, freight and transport mode, the vehicle type, its capacity, Incoterms, and so forth. Then we have the category product, where we put information around the product ID, description, barcode, lot number or batch number related to production, expiration date, unit costs, unit price, currencies, and so forth. And last but not least, we have 3 units of measure. So the reason why we have 3 units of measure, where we can put the quantity, the weight, volume, the dimensions, it's simply to be able to model mixed shipments on the same truck, on the same shipment, or on the same vehicle. So we may have, for example, 5 pallets, 3 cubic meter, and 10 barrels, or 10 crates or boxes. So we have the chance to standardize everything based on these things. Now, why Ginus is unique? It's that it does a lot of checks and validates and checks for errors. It will identify whether the company ID with the company name, they are the same or they are duplicates or multiples. For example, we may have a company ID with multiple company descriptions. This, of course, is not right. So it will capture this, and vice versa. We may have multiple company IDs with the same exactly description company name. And again, this is not right. It will flag it. So it will also do translations of a city from local languages. Let's say we have from ERP systems or a WMS or an TMS, we have a mix of Italian, Czech, Spanish, English, German. Everything will be translated and standardized into English. And from that point onwards, the algorithms and everything can be standardized and harmonized. In terms of the dates, we have the option of using the American style or the European style. So the American style, we have the month first and the date second, day, and the month for the other style. And I'm going just to exclude this for now. But the whole benefit here is that we're setting where the source of the data is, and then anything that is not similar, it will be flagged as an error. And the best way is if we have, let's say, export or a report from an ERP or from a system using the American style on dates, we can have it as a separate upload versus the international or European one. And then we can integrate them, because again, everything will be standardized on the international. The same goes with the imperial versus the metric system. We have feet, pounds, and gallons versus meters, square meters, liters, and kilometers, and so forth. So it's very powerful and saves us a lot of time with not having to do all these checkups and errors and corrections on Excel, copy pasting, moving the columns around. So it's a lot faster if we use Ginus.ai, and we click match all and then begin processing. So now Ginus.ai in the background is doing all these checkups plus a few more. So it takes the spreadsheet, it analyzes it, it finds geocodes for the addresses, or if there are coordinates, it corrects them and reverse geocodes them to see if they are correct. It does all this checkup, duplicates, harmonization, standardization, even the currencies. If we have mixed currencies, everything is standardized into dollar, euro, and British pounds. Of course, we can add more if that's the case. So while this is happening, I'm just going to quickly take you to an existing project. It will take a few minutes to go through all the lines. So in this specific project, there are approximately 1,500 lines. Not much, But the point is we have two files as the end of the process. So when Ginus.ai completes all the checks and make all the corrections and finds the geocodes, it will produce two Excel spreadsheets that you can download. The first is the clean data, and the second is all errors that found within the data. So anything that Ginus was not able to identify or process for whatever reason, it will flag it, it will say the reason, and you can download it. If it's a quick fix, you could quickly change them and re-upload as upload to, and that's one of the additional benefits of having this upload and project functionality. Or you can simply ignore and skip the errors and proceeds with the clean data. So now the data are already uploaded, they are within the Ginus.ai database. Let me go to a file which has more data. So this specific project has approximately 1,000 locations. Let's click the nodes to see the locations. And the reason why we have 4, we can deactivate if you don't like the 4 map windows and you prefer less, but it has the option of creating very quickly different visualizations in order to visually validate the data and understand the data that we have from our file into Ginus. So once we click search, it brings the data. It's like a one filtering, bring me from this project, from this upload the data, and we can further filter by source and destination, country and city, a time frame, product category, and subcategories as well. And we can add more filters if that's required from your side. So this is more just for visualizations. Now the next step is My Seats. Well, it's not actually a step, but it's a functionality, which is very important. My Seats is a layer of locations where we have pre-uploaded to Ginus.ai, and they are representing logistical hubs, locations where it makes sense from a logistics and supply chain perspective. Industrial areas or ports, any place where a warehouse or distribution center would make more sense. So we have linked every single point of these ones with information from the internet around the population in that area, the unemployment rate and the inflation rate. This is fully customizable. You can activate and deactivate the locations that you want. You can upload your own seats that you wish. And this is very important because when we move into running our clustering, our center of gravity, we have the option of using the seats or excluding them or not using them. So this is a very, again, simple and very powerful functionality where the user has the opportunity to make it a bit more realistic. So it's not just the theoretical optimal location, but it's the seat, is the logistical hub closer to the location. In the data, we have pretty much everywhere around Europe. And let's say we want 5 DCs. We can, in this case, let's say that we have a warehouse close to Berlin, and we can fix it just with a right click, or you can select from here and filter and search for the location that you want, which is the warehouse that you want to keep. And in this case, it will bring the next 4 optimal locations. We can use the seats, and we have multiple algorithms to choose from. Let's say we keep the simple one for now, just for the sake of speed, and bam, here is the result. Let's try again now with 5 center of gravities without any fixed ones and using the seats. Let's see how this will, and again the simple one, use the lanes, and we can quickly compare if there is any difference. And as we see here, there is, because here we have in Iberia, Portugal and Spain, we have 1 center of gravity, while here we have 2, and there are some. Let's go for another one as well. Bring me the 5 without using the seats, and let's say this one. Oh, we have an error. What does it say? Some resulting coordinates are located at C. So when we run the theoretical algorithm, Ginus.ai is able to understand whether a center of gravity drops at the sea. And it brings us the 4 or 3, depending, seeds which are closer to that location. In this case, everything is in Germany, so unemployment rate and inflation tend to be the same. So let's say we choose this one, we click, okay, we have another one in Italy. Okay, let's say Napoli, and click OK again. We have another one again in Italy, let's say Palermo in Sicily. And voila, we have the result. Bam. So this is very powerful because in a few minutes we went from an Excel spreadsheet, geocoded the addresses, it cleans for errors. So going to a customer, or you have a meeting with internal stakeholder, you could get your Excel spreadsheets very quickly, put them in Ginus. It will do the structuring, harmonization, standardization. It will find error, geocode, and very quickly you can run live a lot of different scenarios, and you can discuss them with your client or with your internal stakeholder. And this is very powerful because it happens in a few minutes, while traditionally with other models it will take you, the tasks are separate in different modules or in Excel first before you do it on the software. So it takes a lot of time. Plus, it's more expensive. With Ginus.ai, it's more economical and fast and more accurate as well. So this is where we are at the moment. Feel free to ask any questions you may have and reach directly to us. And what is happening in the background, we are developing transport routing optimization algorithms to proceed and develop it further, so that we have, from the center of gravities, we have an analysis of what is the fleet sizing or potential utilization of a fleet, or how many of the orders need to go to a dedicated vehicle or a fleet, and how many they should be outsourced to pallet networks or parcel networks. So this is very powerful to have from A to Z health check analysis of our supply chain within a few minutes, and more accurate than anything else in the market, and doesn't require to have the depth in understanding of the supply chain of the data that you are uploading to Ginus.ai. If you are familiar with that supply chain, that's of course a benefit, but if you don't, with Ginus.ai you quickly get a very good sense of everything is happening. Now, we may want to save the results and then of the scenarios that we run, and then clicking here to my results, the results are saved, and it's an export or Excel export with the allocation. So we have the different results here, as we can see, and we can understand when we open the Excel file the allocations, which customer, which destination is linked to which center of gravity. And that's it. For any questions, reach out to us. We'll be happy to discuss further your queries. Thank you very much.